and welcome to the Halloween edition of Math with Mr. Douglas. Yes, today we are going to be looking at Pythagoras and how we can solve word problems using that classic formula. And in the challenge section, we are going to be looking at Pythagoras and the distance formula. Are you ready to do some math? Happy Halloween! Okay, so let's kick it off. What do you get when you divide the circumference of a pumpkin by its diameter? Of course you get pumpkin pie. And here we go. Today we're going to be talking about Pythagoras. And in particular, we're going to be talking about word problems. So word problems that are going to be involved with the Pythagorean theorem, and there it is, c squared equals a squared plus b squared. There's a couple of classic questions. So let's just imagine that there is a building, and the building is one of those big skyscrapers with windows, and those buildings that, I don't know, maybe Batman stands on top of. I'm going to draw Batman. This is a horrible Batman. It's a man that doesn't really look like, it's like a Birdman. It's not Batman, it's like Birdman with one eye. So Batman's on top of there, and he has no real point in this. But if we wanted to know the shadow of the building, so there's, sunshine, this is our sunshine. And the building is 20 meters high. It's a really kind of small building. And the shadow, so there's a shadow coming down. The shadow is like this. And we actually know that the shadow is a certain distance away from the building. So the shadow lands actually about 30 meters away. So I want to know how long is the shadow. That's kind of interesting. So I want to know what is this length right there. What's the length? So this, understand that we're creating a 90-degree angle when we do this. So any kind of shadow question has a 90-degree angle. And we're just going to go and plug in some numbers. So for this one, we're trying to solve for c. And we're given, 30 squared plus 20 squared. So these are going to be some really giant numbers. And I'll just say that we're trying to find c squared, like that. That's what we're trying to find. So let's go and do some math. So we're going to have, I believe, 900 plus 400 is equal to c squared. So c squared is equal to 1300. And then I need to take the square root. So I take the square root of 1300, and hopefully you're getting thinking of what numbers can multiply to give you 1300, and hopefully you're thinking of I think that would be probably 13 and 100. So the square root of 100 times the square root of 13 would give you 1300, because I'm going to take the square root of both of those, just like this. And that would end up giving me c is equal to 10 root 13 meters. Don't forget to say meters. Classic kid mistake. KKM. Okay, so shadows is an obvious one. Other ones that you might be seeing for word problems is sometimes you'll see maybe some geometry ones. So I'll give you this one. This one's great. It's a three-dimensional geometry. So if you don't know how to draw a cube, here you go. Here's your lesson. Here's your life lessons for the day. You start off by drawing a square. And then what you end up doing is you end up drawing 3 lines that kind of go 1, 2, and 3. And then you just go and join them. Ding, ding. Now to make it really three-dimensional, you want to go and kind of do some dots like this. So it's like that. Can you see the 3 dimensions? Can you see the cube now? Now you're saying, where is this going? Well, I want to know what is the diagonal from one corner to the bottom corner of a cube. So this is a great question, and I'm saying a cube. So we're going to say that the cube is an 8 meter by 8 meter by 8 meters. So it's a perfect cube. And I want to know what the diagonal is. So you're thinking like, well, first off, kids struggle with what is the diagonal? Well, it goes from this corner all the way down, and then it's going to go all the way across, and then up. So it's a wedge. It's a wedge that kind of goes inside. So I don't know if you can kind of visualize that, but that's kind of what's happening. So when you're first thinking about what this would be looking like, you got to kind of go and figure out a few different things, don't you? So you know, if I took this green wedge out, what do you actually know about the wedge? What do you actually know? All you know is this part right here. And maybe I'll just kind of highlight it. You know this part right here is how high? It's 8 meters. Okay, you know that because it's 8 meters. But what about the bottom, right across here? Do you know what this bottom is, the bottom part? You don't. You don't know what this bottom line is. Remember, this bottom line is represented by this line. But do you see a potential right triangle that you could go and make? Well, sure, you could go and make this right triangle, an 8 by 8. So let's go and do that. So we know this is 8 and this is 8. And we're going to figure out this bottom part. And this bottom part is this line right there. So this line, so we're figuring that out right now. Okay, so let's go and do that. And again, we're solving for c squared. So this is equal to, 8 squared plus 8 squared. So c squared is equal to 64 plus 64. So that's going to be c squared is equal to 128. So I need to take the square root of both. And the square root of 128, I think we're going to do 64 times 2. Is that what we end up doing? I think so. 64 times 2, like that. So that would be 8 root 2. So c is equal to 8 root 2. Okay. So now we know that this diagonal is 8 root 2. This is turning into a really pretty cool question. So we've done pretty well here. So we know the height, we know the length, but now we got to figure out the diagonal. That's what we asked at the very beginning. So let's go and figure out what that diagonal would look like. Again, we're kind of going c squared is equal to, and I'll use some brackets for this one, just to kind of make it really obvious. So that's 8 root 2 squared. So what you end up getting, remember if I go and I square this, this would be, well, you can kind of think of what it would be is, just imagine it's right back over here. Like back over here, it's like, hello. I'm going to go backwards. So that's 64 times 2. So that's going to be 128 plus 64. Just like that. So when you add both of those fun things together, you get 192. So c squared is equal to 192. But are you finished yet? You are not finished. You got to think of, could I go and simplify this? So can I go and think of a couple of numbers where this would work out? And I think a 64 times 3, I think that will work out. Does that work out? I think it does. 64 times 3. Yeah, that works out. So you end up getting c is equal to 8 root 3. So there you go. That's what the diagonal was. So you have some idea for word problems. You're going to typically get like shadow problems, maybe this cube problem. But just remember when you're setting it up, another classic sometimes question that you will end up getting is, there's a lake. So here's my lake. And you have to go and figure out, is it better to maybe swim across the lake, or so is it better to go across the lake and you want to get to, I don't know, where do we want to get to? We want to get to a house. It's not very exciting, is it? But you want to get to the house. Maybe there's Somebody's cooking something really yummy inside the house, and you want to know, is it better to go like this, or is it better to swim across? What's the shortest distance, and figuring that sort of thing out. So that's a classic kind of question, because you make a 90-degree angle there, and you have a question like that. So just remember, use Pythagoras, plug everything in, and there you go. We're going to go on to what is kind of challenge. It's not super challenging in the next little part. That's going to be on the distance formula and how that relates to Pythagoras. So this is what I would call a standard, really, but we'll call it maybe challenge for right now. But in reality, I think every student can be doing this one, and it'll probably end up as a standard sort of thing. But we'll throw it in the challenge section. So here we go.
All right, time to get to some challenge work for Mr. Pumpkin. We're going to be looking at the distance formula and how we could be using Pythagoras to do this one. Off we go. Trick or treat.
Hey, what's the favorite sport of your pumpkin out there? What do pumpkins like to play? Squash, of course. I hope you're laughing. Okay, so we're going to talk about the distance formula. And a quick little review. This is your classic coordinate plane. So we have stuff like this going on, and you probably saw some of this earlier in your math career. And remember, you have two different types of axes. You have the x-axis, which goes all the way along here, and you have your y-axis. And don't forget, we always put our coordinates as x, comma, y. So wherever it is, and we start in the middle, and we call the middle, we call it the origin. And if I was to go and say, do this point right here, this would be, 1, 2, 3. So x would be 3, and I go up 1, so that would be 3, comma 1. Okay, just like that. So it's a little reminder of that, because we're going to be using this idea, and this does stem from Pythagoras. So there's a couple of things you're going to learn. So you're going to learn two things. Number one is trying to figure out the distance of a point from the origin. So that's the first thing we're going to learn. And the second thing is the distance between any 2 points. And you might be wondering, like, why? Whoa, 2 points. Why is this in the Pythagoras lesson? Well, it's in the Pythagoras lesson because when you're talking about a coordinate plane and you have let's just deal with the very first part. So the distance, like how far away is this point? And the great thing about Pythagoras is you can go, when you have 2 points, you can use a third point to create a right angle triangle, couldn't you? So if I want to figure out this distance right here, well, we can go and create a right angle triangle and then use the idea of Pythagoras to go and solve for that. So that's pretty cool. Does that kind of make sense? How you could do that? Yeah. So that's one thing that we're going to be doing, and vice versa, or not vice versa, but also if you have just any 2 points, so not dealing with the origin, but any 2 points, you could just go and create a magical third point and then go and figure out what is that distance between those 2 points. So you can use the power of Pythagoras to go and solve stuff. So that's what we're going to be doing today. Let's deal with the very first one. So there's a formula that you need to know. So this is from the origin. So from the origin, how far away is a point? And the formula that we need to know, the distance is equal to the square root of x squared plus y squared. Okay, so that's the formula that you need to know. And let's just go and try this. So here is our graph. And our point is going to be 4, -5. So I want to know how far away is 4, -5. So where would 4 be? 1, 2, 3, 4. And 1, 2, 3, 4, 5. So 4 and negative 5. So right there, I want to know how far away is 4, negative 5 for us. That's what I want to know. Like, how far is this? How far? So don't forget, so remember, 4 is our x, and negative 5 is our y. Let's go and plug in some stuff. So our distance is going to be equal to the square root. And I'm going to use brackets for a very important reason. You can probably start guessing what that reason would be. And I'm going to put 4 in here, and I'm going to put negative 5 in here. Sweet. So what we get is the distance is equal to the square root of 16. Now this is negative 5 times negative 5, so plus 25. So 16 plus 25, I think that's going to be the square root of 41. And can you simplify that? Heck no. No, you cannot. So that's your answer. The distance is the square root of 41. Not too bad, right? Just kind of plug in x, plug in y. It's not too bad. Let's kick it up a notch. Kick it up a notch? What does he mean? Is it going to get more complicated? Well, the formula that you're going to be using is going to be a little bit bigger. And, you know, to kind of get that, you know, don't be afraid. You know, don't be like, if a jack-o'-lantern was afraid to cross the road, you know, of course, he's afraid to cross the road because he has no guts. Yes, that was another pumpkin joke. I feel like I should draw a pumpkin. There we go. And it's going to be, should be a happy pumpkin. Uh-oh. It's turning into a, there you go. It's a happy evil pumpkin, right? It needs a handle. All the pumpkins need handles. So what's the formula? So the formula, I'm going to use orange font. So the distance formula between 2 points. So between 2 points. So any 2 points, not necessarily the origin, between any 2 points is given by this. The distance is equal to the square root, yes, it is that long, is, now this is going to be kind of weird. This is x2 minus x1. That's how you read that. Squared plus y2 minus y1. So it's a little subscript right there, squared. So it's a little bit different. And a couple of things about the x2 and the x1s is you're going to be given 2 points. So for our example, we're going to go and say, what's the distance between 1, 3 and 4, 8? So how far is it between those two? If I wanted to go and kind of visualize that, so here's my coordinate plane. And let's go and put down 1, 3. So 1, 3, so 1, 1, 2, 3. So it's like 1, 3 is about here. And 4, 8, 2, 3, 4, and 3, 4, 5, 6, 7, 8. So 4, 8 is kind of way up here. So I want to know that. That's what I want to know. And when you are given these, you need to go and label your points. Now, it doesn't matter which one you make the first point and which one you make the second point. It doesn't matter. I bet you're thinking this is the first point because it's the first one that you read. So if that's the case, this is the very first x. So we call it x1. And that means that this is y1. And this is x2, and this is y2. So we're going to go and plug these numbers into this formula. So again, distance is equal to, that's a great pumpkin up there. So here we go. So we're going to get this squared plus, this squared. So it's really saying the difference between the x's and the difference between the y's. That's really what you're doing. And so we're going to go, for this one, we're going to go 4. Now this is important. This is 4 minus 1, just like that. And the other one is going to be 8 minus 3. Make sure you get the order right. And if you, for some reason, you made these, you made this, x2, y2, and this is x1, y1, you get the same answer. So don't worry. The math is actually pretty easy to do for this one. So the distance is equal to, what's that going to be? 3 squared plus 5 squared. So we're taking, so this is like 9 plus 25 which I believe is going to be the square root of 34. And ask yourself, can you simplify that? Can you? Absolutely not. You cannot simplify that. So that is two different types of formulas using Pythagoras and the distance stuff. I hope you've enjoyed. And if you are going out trick-or-treating, make sure you're safe out there and you have fun, and don't eat all your candy at once. And remember, you can always bring in some candy for your favorite math teachers. All right, till next time.
The great pumpkin says, well done in your math today. May you have fun trick-or-treating, and remember, be safe out there. Till next time.